Today we are talking about Nebular Hypothesis. Make sure you have the note guide. If you don't, I'll have the note guide in the down below so you can click on it. That's not what I meant to do. Try again. Um, Note guide should say Nebular Hypothesis on it. I'm only clicking on this because this is like our second time taking notes. I want to make sure that you see this. Make sure that you read the need to know. Make sure you have all of the notes so when you're ready for the quiz or the mastery check, you have it all available to you. You do get points for the notes. You can use the notes for the mastery check and on your quiz. So this is all for you to help you learn. So make sure you know what you're doing. Okay. So we have your note guide. You have something to write with. We're ready to go. What is a star? Stars are balls of plasma undergoing nuclear fusion. Stars give off large amounts of energy in the form of electromagnetic radiation. Now, know some of these things we're going to come back to, right? So we haven't talked a lot about plasma. We haven't talked about nuclear fusion yet. We haven't talked about electromagnetic radiation. All of these terms we will come back to at different times. So no panic. Next slide. Okay. A star is born. This is the whole idea of nebular hypothesis. Stars are formed in nebulas. Nebulas are large gas clouds, dust in space. We also call them interstellar clouds. It depends on the book or the article that you're reading if they say nebula or interstellar cloud. This is one of many, many, many nebulas. Just giving you a picture of one so you can see kind of what they look like. Okay, so protostars are formed when the dense areas of gas become more dense due to gravity. Gravity is a key concept here. Make sure you understand that gravity is what is pulling everything together. These dense areas take on definite shape and they are called protostars. Maybe you recognize this protostar. Jupiter is a protostar. For a protostar to become a star, certain things must happen. Obviously, Jupiter has been a planet for a very long time. So, as more gas is added to a protostar, the pressure in the core increases. So, you increase the gas, you increase in pressure. So, more gas, more pressure. As the increase in pressure causes the gas molecules to move faster, this increases friction. So we can do this right here, right now. Put your hands together, and to make your molecules move faster, start moving your hands. Move them faster. You're going to get an increase in friction. What do you notice as you move your hands faster? You should notice that you get an increase in temperature, right? Your hands got warmer because you increase friction. That's what's happening at the core of the protostar. The friction increases, the heat increases, the temperature increases, okay? This is called a domino effect. So gas increase pressure, pressure increase friction, friction increase temperature. If you don't have enough happening, if any one of those things falls out of place, you don't get the protostar going to a star. Just for fun, let's watch the domino effect take place.
All right, go. Here we go. Wow! It's working! Go, go, go. Oh, go, 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 go.
So notice how everything had to be set up just right. If any of those iPhones had gotten pulled out of place, especially like right here at the end, you would not gotten the whole product. And so that's what we mean by a domino effect. One thing starts another, a chain reaction takes place, and if everything goes right,
Yep. Here we
if everything goes right, a star is born. So once the core of the protostar reaches 15,260 Kelvin, nuclear fusion starts. The protostar, so right here, this is the new star. The protostar ignites. You now have the new star. If we don't get enough gas, it doesn't become dense enough, the whole domino effect doesn't get pushed off. Nothing happens. Just like with Jupiter, you have a protoplanet, you have a planet there instead of a actual star. Okay, so what about planet formation? Once new stars form, there's additional material left over in the accretion disk. This material is the dust and the leftover stuff from, the star formation. They start bumping into each other. Because of gravity, these particles will stick together and they form the planetesimals. Planetesimals will run into each other. And again, due to gravity, they're going to stick together and form the protoplanets. Scientists estimate that it took 100 million years for our solar system to go from that newly formed star, our sun, to the planets we know today. And that is it. See you with the next lesson.